Hi, and welcome to this edition of Excel for Introductory Statistics. In this activity, we're going to be doing a problem relating to correlation and regression. And it's going to be similar to the last two activities, the last two videos. In this case, our data that we're working with is basically the percentage of people in a country that use the internet, or we could say internet users per 100 people, and then Nobel laureates or Nobel Prize winners per 10 million people. So that first number, that 5.4, is saying, well, if there's 10 million people in the country, then you would expect 5.4 million people, or 5.4 people to win the Nobel Prize. Now, there's no such thing as 5.4 people, but this is just an average per 10 million people. Okay, so back to the question. We're looking at the correlation between these two sets, and the directions in the blue box, they don't mention find the correlation coefficient, but that we have to do that first before we can answer this question. So what we need to do is find the best predicted Nobel laureate rate, or how many Nobel Prize winners per 10 million would you expect in a country in which 97.5% of the people use the internet. Okay, so that's what we have down here in the bottom left-hand corner. That question mark is what we're looking for. Okay, so to do that, well, there's actually two ways of doing that, and it depends on whether or not there is a statistical correlation. So I'm going to go over here to the second tab where I have, it's called Choice of Prediction. And we have this range of values. Possible values for the correlation coefficient could be anywhere from -1 to 1. Now, you see part of that number line is highlighted green and part of it's highlighted red. Well, this depends on where the correlation coefficient falls relative to the critical value. So if the correlation coefficient is in this red region between the critical values, then the answer is no, and we make our prediction one way, using the average y value. If our correlation coefficient is in the green region to the left or to the right, doesn't matter if it's left or right, but if it's in one of the green regions, we make our prediction a different way. We use the regression equation. Okay, so step one, if we're going to make a prediction, is we have to figure out how we're going to make that prediction, and that's based on the answer to the yes/no question. Is there a statistical correlation, yes or no? So let's start off with the correlation coefficient, and for that we're going to use the built-in Excel function for correlation coefficient. That's equal. Remember, every Excel calculation, whether you use a formula or not, has to start with an equal sign. So equal CORREL. So that's the function CORREL returns the correlation coefficient between two data sets. So that's the function we want to use. And in parentheses, we have to tell Excel where our data is. So Excel calls the list of values arrays. So array 1, array 2. So that first list, we'll call those the x values. We commonly refer to the list on the left as the x values. That's A2 through A24. And then a comma, and then we'll give the y values. Array 2, or the list of y values, I'll highlight those. Or you could type in manually B2 colon B24, either way. And so we get a correlation coefficient of about 0.695. I'll round that to 3 decimal places because our critical values are also rounded to 3 decimal places. So now, well, what does this tell us? What is the answer? Is it a yes, they are related, these two sets are related, or is this a no? Well, for that, we have to determine what is the critical value, or critical values, plural. So if I draw a little number line here, we'll put 0 in the middle. What are our critical values? Well, we need two things. We need the level of significance, and that's got to be given in the problem. So use a significance level of alpha equals 0.05. What that simply means is use the middle column. Use the column that's labeled alpha equals 0.05. And so I'll highlight this. Let's use blue for this. Okay, so we're looking at this column of critical values. And we need the size of our sample. What is n? And for matched pair data, for correlation coefficients, n is the number of pairs of data. All right, so it looks like we have 23. 23 pairs. So it goes up to row 24, but row 1, there's no numbers there. So 23. On this table of critical values, there is no 23, so we'll round up to 25. And I'll use yellow for that. Yellow and blue make green. So when I highlight the row for 25, you'll see where these two overlap. Just turn green. And so our critical values are plus or minus 0.396. So we'll put 0.396. We'll have a negative 0.396. So anything to the right of 0.396, we would say, yes, there's a correlation. Anything to the left of negative 0.396, we would say, yes, there's a correlation. Anything between them, we would say no. And our correlation coefficient is definitely in the yes range. So that's R equals, what did we get? 0.695. Okay, so our correlation coefficient is to the right of the positive critical value. So I'm going to go back over to this second tab, choice of prediction. So we're not there, even though the right and the left is the same method. We are here. Right, the answer was yes. There's a statistical correlation. So now, to find the best predicted y value, we have to take that given x value and plug it in to the regression equation. Plug it in and solve for y. Plug in the x and solve for y. And the way we do this on Excel, well, first we'll make a scatter plot. We'll add the regression line. Display the equation on chart. That's the y equals mx plus b regression equation. And then we'll plug in the given x value. So let's go through those steps using the data that we have. Okay, so back to the first tab. So first, let's graph this data, these matched pairs. We'll graph them as a scatter plot. So highlight our data. Insert, and we'll pick the icon that looks like the graph we want. We want a scatter plot, and that looks like this one down here. All right, so there's our scatter plot. We don't need to do much. We don't need to do anything in terms of editing right now. If you want, we can format this axis. We don't need all this empty space to the left of 40. So let's just, this isn't necessary, but just for the sake of this video, I'll change the minimum x value to 35 instead of 0. So that'll just spread out these points. Remember, each point corresponds to one pair of numbers, one x comma y pair. All right. So now we want to add the regression equation. So select the graph, which is a scattering of plots of points. So you could click on any point you want. I click on one point, and now you see all these points are highlighted. And now I'll right click. And I want to format the data series. Format means change or add or edit. So format data series. No, actually, sorry. We want to we want to add a trend line first. Okay, so in statistics, we use the term regression line and regression equation. In Excel, we use the word trend. Well, Excel uses the word trend line. They mean the same thing. So we'll add a trend line. So now this is the best fit regression line. And we need the equation of this line, y equals mx plus b. So it's very easy to do. All we have to do is check this box. The second from the bottom, display equation on chart. So once we click that, now we've got our equation. It's usually going to be small and in an inconvenient place. So we could just move this over here, wherever we want. And we could even increase the font size. Okay, so now we've got our regression equation. Y equals 0.4462x minus 22.55. So to find the best predicted, we can get rid of this edit screen on the right, to find the best predicted y value. Okay, so I'm looking right here now. Answer the question. Best predicted y value from the regression equation. We take the x value. So we're basically plugging it in for x. So we're going to let x equal 97.5. So plug in 97.5 for x, solve for y. So we'll do 0.4462 times 97.5 minus 22.55. And I'll type that in directly into this cell right here. So equal, remember, if Excel is going to do a calculation, we need to start with an equal sign, equal. And I'm just going to type in exactly this regression equation, except instead of the x, I'm going to insert the number 97.5. So we've got 0.4462 times 97.5 minus 22.55. And so I've just taken that regression equation, replace the x with the 97.5, enter, and that's the answer to our question. We could round this to 1 decimal place because all the other y values or Nobel laureates per 10 million people, these are all rounded to 1 decimal place. So let's be consistent with our rounding. So I'll use the rounding icons on the home ribbon. So to answer the question, how many Nobel Prize winners would we expect per 10 million people? If 97.5% of the country's people use the internet, we would expect 21 Nobel Prize winners. 21 Nobel Prize winners for every 10 million people. All right, that does it for this. This is our third and final example of correlation and regression.